Hello all, welcome back everyone. So we are in the part 2 series of DeepSeek, understanding the DeepSeek. In the part 1 we have covered the basics that are required to understand um, the model, to understand the DeepSeek. So in this video we're going to talk about more about the DeepSeek architecture and the training strategies and how they have approached the problem and all. So yeah, before going to there, I just want to start with quick recap. And then one big disclaimer is that if you are directly coming here without watching the part 1, I strongly recommend you to watch the part 1 and get some basic understanding and then come for part 2. Okay. Yeah, uh, that's being said, um, in this part 2, before we start, I just want to I just want to quickly give you the recap that what we have done in the part 1. So the part 1 we have seen that reinforcement learning, the basics of the reinforcement learning, try to explain, and uh, and then this is how it will be for an input query, right? The model, under pre-trained model, there will be a reward mechanism will be there. Based on that reward mechanism, there is a PPO, uh, proximity policy optimization will happen based on the r theta values and all, and the policy pi will be updated to the basic model. So this will happen for certain series of things, certain series of iterations and for model finally will understand or more tuned towards the what human is looking for or what towards the desirable outcomes rather than the default outcomes, right? So this we talked enough about the PPO, and this is objective function that it tries to minimize, or it tries to solve during this PPO optimization, right? If you want me to just quickly recall that this particular equation, there is a r of theta using this value, right? With the current policy model and the old policy model, we're gonna take the ratio of the what is that ratio of the given query. For a given query, what is the probability of generating that particular output with the new as well as the old policies? That ratio we call it as a uh, I mean what we say that sampling ratio, right? Important sampling ratio. That particular sampling ratio, we're gonna use it as the objective function, and that r of theta is nothing but our important sampling ratio that will be multiplied with this advantage number. In this video we're going to talk about this advantage number a bit more, and I already explained this clip function and how the value will be clipped without going too much extremity. This clip function and all, how it helps, we have discussed enough on that. And this is the r of theta, this is the pi with the old, and sorry, the denominator with the pi is the policy, with the policy is basically the update, right? The update that was feeding to the LLM, we can also call it as a policy, nothing wrong in that. So that probability and the new policy probability for predicting the output for a given query, right? So this is r of theta, and also the advantage. In the earlier video I have not spent much time on the advantage number calculation, because if I speak more about this math and all, the particular video will become bore, and even though the video become very long, and that will make more boredom, right? So in this video I just quickly talk about this advantage number. What does it mean is, like, this is just a simple difference between the q minus v. Q, where is q is, like, this is also a reward. If we expected reward, right? Expected reward, if we consider the output for given query q1, let's say this query q1, right? If we consider the same output, what is the reward we might expect during this PPO, during the PPO optimization, right? That reward is, we call it as QO, and this is VQ. V is nothing but the expected reward. Reward is basically a return or the magnitude of feedback that is coming from the current sample, something like that, right? So yeah, the expected reward from the current policy pi from this query. So this is V, and the difference of Q minus V is our advantage number. Let's not worry about too much about this particular advantage number. I'm gonna give some example, very basic example. Let's say I in Hyderabad, right? In Hyderabad, right? There are number of restaurants. If someone asks me, right, how do you rate food in Hyderabad? Okay, nowadays the food is lot of contaminated in Hyderabad, I would say that 5 out of 10. How did I say? Because I have pre-trained knowledge, because I have explored enough number of restaurants in Hyderabad. I know this, how the food is cooked and all. Based on that, I have given 5 out of 10 based on my pre-trained knowledge. Pre-trained knowledge here is like I have explored enough number of experiments till yesterday. Okay, today my friend, my friend or someone, my friend suggested one more restaurant, and he say that that is too good in taste. Okay, that is the feedback I got from my friend. Okay, what feedback I got? My friend say that one of the restaurant is really delicious. If you are planning for a restaurant next time, just go to that restaurant A or B. Okay, so and keeping that in my mind, if I want to go to the restaurant, I will not go to the old restaurant, rather than I'll go to the new restaurant, because he suggested me to go to the restaurant. And after going to the restaurant, let's say if I rate that restaurant, if someone asks me to rate the restaurant, if I rate it like 9 by 10, right, that means I have changed my opinion, right? Changed my opinion from where? From the feedback that is coming from my friend, right? So this is like a, I mean, it's not mathematically directly related. I'm just trying to map this particular scenario with the advantage number. Just try to think of in that way as well. So this is our V and this is our Q. Okay, and this is our Q. This is my overall aggregated response, aggregated pre-trained knowledge, or aggregated opinion, I would say, I have on the restaurants. And this is the response, I mean, this is the rating that I got it from based on my friend's feedback, my feedback, right? So if I take the difference here, what is the difference? Q minus V, right? Q minus V is nothing but the negative difference, minus 4 it will come. So this is minus 4, which means that I need to penalize my learning going forward. I have a very bad opinion about the restaurants, right? But with this particular experience, I feel that okay, there are some good experience. There are some restaurants also which are good. That kind of update, I will do it in my mind, right? So this minus 4 will penalizes that particular thing into the LLM as well. So this A is nothing but this is what we call it as advantage number. That is what it is contributing here in this particular equation. And I can give you one more example, most somewhat technical example, right? For example, imagine that you are chatting with a chat GPT, right? And you ask a query. Okay, I will ask like I will say like Q1, and you sent like my network is not my network is not connecting, not connecting. Arey yaar, not connecting. And what this GPT will say? O1 is output 1, right? Oh sorry, oh sorry, something like that it will say, right? Oh sorry to hear about it. Hear about it. Can you try restarting your system? Can you please try? Something like that it will say. Try to solve the problem that you are that we are basically facing, right? Please restart your PC. Something like that it will say. And right. So whenever, okay, whenever you are, okay, let me take one more. I don't know, okay, for some reason it's not working, it's hanging actually. I'm gonna close this. Let me use this white page, because that is the Microsoft is hanging a lot due to some issues, I don't know. So yeah, what I'm saying over here there is like you have given a query 1, my internet is not working, oh, my network is not connecting, something like that. And output 1 will say like, oh sorry, or something, some message it will say, right? Oh sorry, can you try restarting your system, something like that, it will generate it. This is the query and this is the output. So what if you say that yes, it worked, something like that, it makes a positive impact, right? And model will things like whatever the solution it has given, that is aligning to the question that what you have asked, right? The solution is aligning kind of, right? Then a of a value will be positive and there will be no penalization will happen. Say for example, instead of saying yes it worked, instead of the user is frustrated and say that no, this is a very basic, this is not gonna work, not gonna work or something like that, not gonna work, I already tried kind of response he given, in the sense this is like a negative feedback, and the model should update this particular thing into its network, right? So whenever the other user asks this kind of question, it should not give this kind of answer, rather it should give some other answer, but this is not for sure, right? That kind of understanding you should go. These particular things can be controlled with this advantage number. Here the negative, in the sense there should be a penalization should happen during the reinforcement learning. The advantage number will be negative here, that means the penalization will be stronger. The magnitude and all will be calculated with that q and v parameters. Hope you get it, right? So from now we're going to talk about the DeepSeek, right? DeepSeek model, DeepSeek R1 to be precise, right? So for every research, right, there will be a starting problem will be there. We will start understanding what they are posing as a problem, and after that we're gonna see like what is our objective and what is the approach to solve that problem. And we can see like how the reinforcement learning helped them by improving the reasoning and all, right? So the current problem with the current LLMs, what they are claiming, right? So we have a lot of LLMs, right? We have a lot of LLMs, in the sense some of them are like Mixtral, Mistral also one of the LLM, and we do have Llama, right? These are like open source LLMs as well as the closed source LLMs, something like GPT 4o mini and o1. These are like very powerful LLMs which are available at some certain price, which are very costly also. So what they're claiming is the problem with the current LLMs that are there is they are good at generation text, could be these open source LLMs, right? Or else many LLMs, right? Good at generating the text, but what they are lacking is they are lagging at the what? Yeah, let me change this size. They are lagging at the reasoning capabilities. They are lagging at the reasoning capabilities. This is very important. So whatever that there are a lot of techniques that are followed to solve this reasoning problem, but still it is these LLMs, right? Whatever the LLMs that are coming into the community, open source community, they are performing okay. They are performing up to the mark, just up to the mark, but they are not dominating the performance of the GPT-4. Okay, but the DeepSeek has achieved this reasoning, right? So but we'll see, like, but this is the problem they are posing, right? So they want a model, right? They want to solve this problem by imputing the reasoning. The model should be able to learn the reasoning for the given input or whatever, right? So the problem is clear, right? The reasoning, so the learning, the LLM, what they're gonna build it, right? The LLM should be able to get the reasoning as much as possible. So that is what the objective, right? Objective for them is like, for the model what they're building, right? For the model what they build or train it, that should increase in reasoning performance, that should increase in the reasoning, that should increase in the accuracy for reasoning capabilities, right? This is very important for reasoning capabilities. So this is the objective they have made it. So they want an LLM that should be able to improve the reasoning, correct? So on being said this with this particular objective, they need to follow the approach, correct? they have they have followed the approach, they need to follow the approach, even anybody, right? They have to follow the approach, right? So what approach they have started is they have started with one single approach, one beautiful approach at the starting, and later they realized that there are some more problems in that particular approach, and those problems also addressed with the some other techniques. We're going to see one by one. So we're going to start with the basic approach what they have started. So for any algorithm, right, to train it or to build it, right, so typically we need to consider one we need to consider one base model, right? Base model. So that base model is DeepSeek v3 base. This is a base model that's been, this is already pre-trained base model. This is something like a llama, Mistral, those kind of model, but this is owned by the DeepSeek itself. They must have trained in the past, right? This they are considered as the base model. Okay, and of course this base model also builds on like transformer architecture and all. We can go into that details later, but for now we can think it like this is a pre-trained model they have considered as a base model here. So what they have done, this is a pre-trained model. Let me write it here. This is a pre-trained model, and they have simply added reinforcement learning. Remember, reinforcement learning, we have had enough discussion in the part 1, right? In case if you are not sure, just go and check the part 1 again, you will get some idea. Reinforcement learning, here the technique they have used is called GRPO. And GRPO we have seen in the part 1, right? Part 1 of this video series, we have seen about the PPO. PPO is one of the reinforcement learning algorithm, and GRPO was also one of the such algorithm that was there in this particular paper. And this is how they have initially trained. Okay, they have initially trained entire this thing, means there is no supervisor fine tuning is involved here. Supervisor fine tuning in the sense, for every input there will be a desired output. Okay, we have this kind of data, and initially that training will start, then we call it as a supervisor fine tuning. Means we are providing the data, right? For this input, what should be the output? So that kind of thing they are not providing in this particular framework. They're just clearly based on the reinforcement learning, that too based on the GRPO. Okay, so and they call this model as, this entire model they have fine-tuned with the RL up to some epochs or some steps of training, and they call this model as DeepSeek R10, the base model or the pre-trained model, which is further trained using the reinforcement learning and using the GRPO method, right? This entire model is they called as a DeepSeek R10. So very, very important. So with this exercise, what they have observed is like whatever the learning that is happened with the reasoning. So this model increased the accuracy in reasoning increase in accuracy drastically increased, not just increased, drastically increased. Okay, even they also surprised, it seems. So they have not expected that much of result. They are like, with this capability, the reasoning was almost all matching with the OpenAI, right? OpenAI GPT O4 mini, sorry, O1 mini and O1, right? They also surprised, and but the reasoning is highly drastically increased. But what they are lagging is there are two potential problems that were raised here. I'm not sure whether two or not, but they have mentioned two here. Like, one is the poor readability. See, whatever the outputs that's been generated at this stage from the DeepSeek R10 model, that is not that is not that much easy to read. And I mean, users feel like, I mean, for a user it feels like it is very difficult to read that particular that particular output that is generated by this particular model. And the second most potential problem they have occurred is like language mixing. This is also a very potential problem, if you ask me. Like, the output generation is some of the text is generated in English, some of the text is generated in Chinese, right? This is like not that much good, right? So of course at the reasoning capabilities it is outperformed, but still these two are the very potential problems which will stop us to make it at a standard level or industry level, or to make it open source and all, right? These two are like, potential problems they have identified. These two problems also addressed strategically, but before going that, I just want to spend some time on explaining this GRPO. What is GRPO? If you recall, like PPO, there we have R of theta. R of theta is like, policy, new policy of the for a given question. What is the probability of generating the output with the new policy divided by the with the old policy? Sorry, this is the old policy for a same output for a given questionnaire query. So this you remember. Let me go back to the paper. There we have like have that equation already written. Why to write it again? Let me go over there. Yeah, here I guess. So yeah, this is what we're calling as a GRPO, right? GRPO, group relative policy optimization. Earlier that is like a PPO optimization, right? This is a group relative policy optimization. The major difference you see here is here this is a group, right? And the same equation like minimum, and this is, if you recall, this is a r of theta, and this is the advantage number. Here the advantage number is slightly differ, we'll discuss. And the clip function we have already seen, this is also r of theta, and this is a 1 minus epsilon, 1 plus epsilon we have seen, that is used for the clipping. And this is again advantage number, and this entire term is used for the regularization, which I'm gonna explain what is that. Okay, and if you look at it, there is a what we can say, there is a there is a major difference between the PPO and GRPO. PPO, right, whatever the outputs that are coming from the model O1 or O2 or O3 or O4, right, these particular models are ranked, right, and whenever we are policy updating, each and every output is taken individually. Whenever we are taking the output of O1, we are not putting the O2 or we are not showing impact of O2 while we are updating the O1. So whatever the updates that we are doing it independently for one query, right? That was happened in PPO, right? What I mean by that, whenever we are doing the update for O1, we are not considering the impact that is being created by the O2. So whatever the updates we are doing, that's been happened independently for whatever the outputs that we are doing. But now here in the GRPO, this is somewhat different. So let's say for one question there are like 10 outputs are there. So these outputs, right, these outputs are ranked and rewarded, right? After rewarding, what will happen is, right, every this entire outputs, along with the ranking, it will also take the information how this output one is differ from the rest of the outputs. That kind of information also we're gonna carry. So whatever the output we are taking, along with this output and also the entire group information also, we're gonna carry towards the policy update. So I mean, somehow we are carrying that. How we are carrying, in the sense, I'll tell you. See, let's say we have group one group, right, for one output. Let's say there are 10 groups, so 10 outputs will be there. Those 10 outputs, right, we're gonna take we're gonna take the sum of each and every outputs sum, right? For O1, what is the sum? For O2, what is the sum? O5, that sum we're gonna take it, and that is entirely for one. For that sum will be penalizes that particular learning, and this particular term act as a regularization. And the regularization, what I mean by regularization, see, keep in mind that whatever I have said, that whatever the values that we are updating via feedback, right, that feedback should happen very control. It will be it should happen in very controlled manner. It should not be like, explode, or it should not learn from it should not learn from too much from one or two samples, right? To save that, we are using this divergence, scale divergence, and this beta is a one more hyperparameter. And in more or at higher level view, this can be also act as a regularization parameter, so that how it helps is, it helps the model training to not too much overfit from the singular small set of samples, right? And here you can see, if you see, epsilon and beta is the hyperparameters. I mean, hyperparameters in the sense, to make it more converse, this epsilon and beta can be given with some set of values. Which values works better, that value will be finalized. And this is the DKL, which is the KL divergence. The KL divergence formula is like this. So this will give an idea like how the current pi of theta is a current policy. Current policy is deviating from the reference policy. They have some reference policy, they might have set it. So it will give the magnitude of like for how the current policy is getting deviated from the given reference policy. That kind of understanding it will give KL divergence. And if you see that here, the advantage number is like nothing but, since we are operating at the group level, we require what is the information along with each and every group, right? So this R1 is the rewards or the rankings. Rewards are like marks here, so rankings for that particular group. And what we are seeing, for every reward, right, for every reward we are taking the mean of the entire group and the standard deviation of entire group. So what it will contain, for every output sample, it knows, we are also carrying the information of what are the information across the group, as well as the current output state also, right? So this will, in this way, it will carry the entire output, entire group output, to maximize it. I'm sorry, to submit all the value, all individual pieces in that particular group. The summation will happen. This is only the major difference between the PPO and GPO. And with this GPO, right, they have observed GRPO. With this GRPO, they have observed the reasoning capabilities are increased massively. Okay, but let's back to our steps and approaches. So this is the approach they have followed to solve the reasoning capabilities. With this, the reasoning capability is solved, but the poor readability is one issue they have erased, and it was erased. And the language mixing is also one of the drawback, one of the potential problem that was erased. How they're going to solve it is, this is the final model which I'm talking about. This can be a final model. In final model, what they have done, I'll try to give in a stepwise manner what they have done. In the step 1, right, since there is a problem with the readability and the language mixing, what they started is cold start fine tuning. In the step 1, they have started cold start fine tuning. They call it as a cold start fine tuning because they don't have any fine tuning data at this stage, right? That's why what they have done is they come up with some curated data which will have again, this is a SFT, supervisor fine tuning. They have set of inputs, and for each and every input they have a output. Okay, output, something like that. They have created one structure like this, inputs and outputs. These inputs and outputs are carefully curated, and each and every input will be in such a way that it will be at a richer readability, and each input and output pair will have very rich in readability. And what it will have, and there is also addresses the language mixing, right? That is also, it will the pairs will have in such a way that it avoids the language mixing and all. So what happens is, the authors collected this kind of authors who trained this particular DeepSeek R1, right? They have collected this kind of inputs in the thousands, probably 10,000s, I don't know, some big number. And then they started fine tuning the, what we say, they started fine tuning the DeepSeek, the base model, right? DeepSeek v3 Base. This is a base model. Done. This is a step 1. What is a step 1? Fine tuning. Cold start fine tuning. Okay, let me, I don't know, some lagging is there in with this whiteboard. Yeah, let me write it down here. Cold start, right? Cold start fine tuning. The arrow should be in a reverse direction, my bad. So the fine tuning will happen after that step 2. This is a step 1 done. Step 1 done. And step 2, what they have done is, in the step 2, what they have done, they have used the reinforcement learning here. That what we have seen in the earlier approach, right? Reinforcement learning. Reinforcement learning that we have seen RL. The same reinforcement learning after the cold start problem is solved. I mean, after the fine tuning with the cold start fine tuning data, they have implemented the reinforcement learning with GRPO mechanism. Okay, yeah, the same GRPO mechanism is the one which we have talked just now, right? With this mechanism, this is the objective function for that GRPO, and this is how at each and every group they're gonna, I mean, for each and every question they're gonna query, they're gonna generate the 10 or 20 groups, and each and every group was rewarded, and that rewards are aggregated with the aggregated and taken the advantage number, and they have taken this kind of everything, right? The aggregation parameter, they have taken care that it should not exceed too much than what it is really required for the learning, and everything is controlled by the C question. So that GRPO learning will happen. Okay, and with this actually they have addressed 3 problems. Reasoning done with this reinforcement learning, right? And what else? And that poor readability sorted, because they have carefully curated few thousands of data, and they have addressed that problem by fine tuning. This poor readability is also gone, and language mixing also gone at this stage. Language mixing is also gone. So readability is working phenomenal, and these 2 problems also nullified here. And now let's go for the step 3. Why step 3? I'll tell you. So with this, right, with this fine tuning, right, all these 3 problems are vanished, and in the step 3, right, the model whatever evolved so far, it is very powerful. It became very powerful. It can know the reasoning. It can also know how to generate output for a given input. So to enhance it more learning, what they have done is self-supervised learning. They have implemented self-supervised SFT, right? Self-supervised learning technique. Self-supervised learning. So this is also one of the SFT, supervised fine-tuning technique, self-supervised fine-tuning. So what they have done with this model, they prompted, or they have somehow prompted, or somehow they have created the data set using this model itself, which we have done so far, which we have completed till step 2, right? Which we have built at step 2. With this model, they have prompted, or they have done something, right? So that the model itself generates the new data for a given input, right? They have prompted or something like that. The model itself generate the new data, something like a new questions or new coding questions, something like write a prime number program. I'm just giving an example. Write a prime number program in Node.js, in JS, JavaScript, or something like. If this is a question also generated by this model, and answer is also generated by this model by simple prompting, kind of thing they might have done. Because of that, answer, query, and the output also will be generated. Output is some JS code for prime number. So again, with these kind of examples also, they have implemented self-supervised fine-tuning. So with this prompting or something like this, they have generated there could be thousands of questions or more number of questions, some metric questions they have generated, and these questions also helped in fine-tuning and further learning the further learning the making further more intelligent the model, right? This they call it as a self supervised. This happens at the step 3, right? And after all this self supervised fine tuning, step 4, right? Step 4, they have implemented one more one more final reinforcement learning on top of all of this. Okay, so for whatever we have built for at the step 3, they have implemented this is again. So let's say this is a model again that is built till step 3, right? And again they have implemented the reinforcement learning for better results. In this reinforcement learning, it is not just specific to the reasoning. There, if you in the first step also we have in the first step, right, they have introduced a reinforcement learning that is more objectified for the reasoning, but here it's moreover not just for reasoning, for everything. So in this process what they have included: factual questions, factual QA, and here the fine tuning is for here reinforcement learning is focused for factual QA, and what is this, what else, writing data, and what else, right? And self cognition, and and then and there could be other things also. The factual QA is something like, so far it is good at reasoning, but if they ask questions like what is the capital of India, it should be able to tell New Delhi. That kind of feedback also they have introduced in this particular reinforcement learning stage. And also writing data in the sense generating the new data, or kind of chit chat kind of data, generating the text kind of, generic language, typical like a language model behavior, I believe. That will be also taken care in this reinforcement learning step. And self cognition is like the model sometimes might fail to address the or give the solutions for the math problem or coding problem. That identifies itself, and it will be feed as a it will be feed as a reinforcement learning layer, and that will be also addressed in this block. This is step 4. And the step 5 is, and they are claiming like there are a lot of models are there, variants of the deepseek, right? And deepseek, okay, by the way, in the step 4, right, in the step 4, this entire model so far what we have seen, they are calling it as a DeepSeek R1. This is the model. Now it started outperforming the GPT in terms of the reasoning, in terms of the generation, and all the benchmarks you can see it here. Okay, in the abstract itself they have shown us these are all the benchmarks, right? This y-axis can be the accuracy and x-axis can be the different data sets, right? And the brackets, the text, that is the performance metric. And these are the different data sets. If you see that dark gray color, I don't know what's this called. For me it's a gray color. I don't know how people will call this as this gray color, right? OpenAI O1, which is a GPT O1 model. It's increased in some of the cases, it's increased the accuracy, right, with this approach, which is a mind-blowing. Because of this only a lot of tech giants like Nvidia, that shares gone down, but that's a temporary glitch. I'm sure the market gonna regain very soon, because understand Nvidia and Google will have a lot of research laboratories and research areas like this, so they know how to market everything, so we don't want to worry about them, right? So but the point here is like, because of these particular benchmarks, right, it's outperformed the OpenAI simply, right? So far this is called as DeepSeek R1, the model that was built till step 4. They're claiming as a DeepSeek R1. And the step 5, this DeepSeek R1 further distilled for smaller models. There are a lot of variants are there, 13 billions or 7 billion, I don't know. There could be, okay, let me check in the internet itself. DeepSeek distilled models, right? Distilled models, all versions. They have introduced all versions here. See, of course this is not an official page for this is not an official page for DeepSeek, but let me check. Yeah, DeepSeek R1, they have digital models. Basically, digital models are nothing but, right? If you see that this is a DeepSeek R1 digital Queen 1.5 billion, so which is digital for the, I mean, whatever the model that we have seen, this will be very big. That might require big compute mission to use this vanilla model. So they further downgrade, I mean not downgrade, they further reduce the size with some optimization techniques and all to the smaller models, so that we can use it in our systems. 8 billion models version is there, and 7 billion model version is there, and 70 billion model version is also there. I think this is the official GitHub page for DeepSeek R1. So if you are interested, right, you can also download your model into the system. You can use it. I am using it, but currently, right, because of the lot of load, I don't know, it's not working. But I can do a separate video for that as well. If you are interested in that, let me know in the comments. So this is how the DeepSeek R1 steps are involved. I'll just try to reiterate. The step one is a cold start problem. They have fine-tuned, or not here, the final the basic approach, right? They have taken the DeepSeek v3 base model and they have applied reinforcement learning with GRPO method. With that, they have seen that the reasoning is increased like massively. Reasoning accuracy was increased massively, but there are two potential problems. To address that, the final model is like this: the cold start fine-tuning, right? That was being addressed for solving the problems that what we have seen in the base approach. So they have used the SFT fine tuning here. So after SFT fine tuning, in the step one, the reinforcement learning that is there in the approach one, they have introduced here. With that, the poor readability is gone, language mixing is gone, and also the improved reasoning is coming, and also self supervised fine tuning. So once the model is built here, using the same model itself, they have generated the many set of questions. That questions will again use for fine tuning for itself, right? The model itself generating the questions and fine tuning the model itself, that is also improved a lot. And also one more finer RL reinforcement learning happened, uncovering all the aspects. Here the reinforcement learning majorly focused on the reasoning side, but here it covers all the picture, overall picture, like factual QA, writing data, self cognition, everything's covered here. And step 5 is the distilled, right? Whatever the model that is built, that is called as a DeepSeek R1. So where the base model is the DeepSeek v3 base 3, and this model, right, with the RL GRPO is called as DeepSeek R10. Okay, DeepSeek R10. And this is after the step 4, they call this as a DeepSeek R1, which is outperforming as a GPT, and they have distilled into the small model after using some distill mechanisms and all. Okay, this is about the DeepSeek, and few more interesting things in the paper. You could also read it because now you hope you get some idea to understand what DeepSeek and all, and what's reinforcement learning, how it helps and all. You might have understand. So you can also go through this paper again, so that you will also, now we will able to understand after seeing this video for sure. And one more, what else? Yeah, this is what they're claiming, that aha moment. Of course, they don't mean that OTT platform that is there in India. This is like some of the movement, right? While the model itself, they also observed, right? While the model itself is learning something, the response, if it feels that this is not a correct response, it is again penalizing that particular bad response, and by flagging it, and it's re-evaluate the step by step to identify the correct sum. This is also a very good example they have given it. And what else? There is also one beautiful thing, I guess they have mentioned in the table 1. Let me check table 1. Yeah, template, right? This is the template for DeepSeek R1. This is the template for DeepSeek R1, right? For training. So in this template, actually they have trained. So they have considered this: the user asks the question and the assistant. This is how the prompt or the training sample will look like, and the answer is always, they make sure that they are putting in this answer tags, and thinking pattern should be always annotate in between the think pattern, and here is the user prompt they are mentioning, and the assistant is like, the output of the model that needs to be coming. So this is how they are saying that they have constructed this training template, and with this template they have trained it. So for, I guess I have completed on interpretation of this particular paper, DeepSeek R1 paper. Still, if you have in case any questions, feel free to comment down below. I'm gonna address it very fast. So happy learning. Again, I'm saying, like, being a engineer, you should be very, it is very much important to understand the technicality around the world what is happening. So happy learning, all the best. Goodbye.